5 or Chapter 5 with Section 5.7, Solving Quadratic Equations by Factoring. A quadratic equation is a polynomial equation in one variable that contains a variable term of degree 2 and no terms of higher degree. So these are just two separate examples of a quadratic equation. Note they both have the same variable. In this case, this one has a z, no other variables. This one has a k, no other variables. And the highest degree is 2, exponent of 2. All right, here's our standard form. Ax squared plus bx plus c equals 0 is what a quadratic equation looks like. We're working with real numbers. Just some factor properties. If you're multiplying two numbers and you get an answer of 0, then one of those numbers has to be equal to 0. You learned that in first grade. Okay, so solving a quadratic equation. Make sure the equation is set to equal to 0. Factor, if possible, the quadratic expression that equals 0. Set each factor containing a variable equal to 0. Solve the resulting equations to find each root and check each root. So let's use those steps and practice. Solve the equation to find the two roots, or the two numbers that would be answers that would make this work for x. So first we can make sure the equation is in standard form. That means that we have the highest degree to the lowest degree and no degree variable set equals to 0. Factor, so we can ask ourselves what two numbers multiply to equal 20? Negative 20. Keep in mind one of them has to be negative. And add to equal negative 1. 5 times 4 is 20. Negative 5 plus positive 4 equals negative 1. So there's our two numbers. Set each factor equal to 0. So you're going to set what's in the parentheses on the left equal to 0 and on the right equal to 0 and solve for x. So we'd have to add 5 to both sides over here and subtract 4 from both sides over here. And our two solutions would be x can be equal to 5 and x can be equal to 4. Negative 4. Sorry. So let's check those and see if it makes sense. If we replace x with 5, we'd get 25 minus 5 equals 20, and that is true. If we replace it with a negative 4, we'd get 16 plus 4 equals 20, and that is true. So x can equal 5 and also equal 4. Here's another example. So first factor, 2x minus 1 and x plus 7 equals 0. Set both quantities equal to 0 separately, solve for x, and we get x equals either 1/2 or x equals negative 7. Okay, just to review the factoring here, the coefficient was used saying, well, 2 times 1 would equal 2. And then we're figuring out, well, what could we multiply to equal negative 7? That would be a 7 and a negative 1. And we can just double check that when we do our inside terms, it should equal 13. So that would be our outside. 7 times 2 is 14. And our inside, negative 1 times x is negative 1. And 14 minus 1 is 13. So that does work. Solve the solution to find the roots. So here we could factor out an x. They both have an x. If we take that out, we can set x equal to 0 and set the 7x minus 3 equal to 0. And we end up with two solutions that both work. Okay, we'll just go through a couple more examples here. Solve the equation to find the two roots. So we can first rewrite this because this is not in our quadratic form. We'd have to do a x squared plus x minus 12 equals 0. So we had to rearrange this so that it was in quadratic form. Then let's factor that out. 3 times 4 is 12. One of them has to be negative. The smaller one from 0, this absolute value, because our middle term's positive. So 3 is negative, 4 is positive, and then we can set both of those equal to 0, solve for x, and check both solutions. And they do both work. So here's an example relating to a rectangle. The area of a rectangle is 84 square inches. Determine the length and width if the length is 2 inches less than twice the width. So let's make sense of this problem. Let W equal the width. Let 2 times W minus 2, because it's 2 inches less, subtracting, then twice 2 times the width. So 2 times the width minus 2 equals the length. So our formula for area would be, it is length times width. If our area is 84, we're going to replace that length, L, with our equation 2W minus 2, and then multiply that by our width. We can then rewrite that same, this is what we ended with, 84, our area equals our length times our width, and then we can simplify and distribute that W in to solve for W. So we have 2W squared minus 2W. We can rewrite this in our quadratic form, 2W squared minus 2W minus 84 equals 0. Factor out a common factor of 2. Okay. Factor W squared, our trinomial here. 6 times 7 is 42. Negative 7 plus a positive 6 would equal negative 1. And then set all 3 values, not just one, equal to 0. And the only one that originally doesn't work, we can see right away, is 2 is not equal to 0. But we can solve for W equals 7. We can solve W equals 6. With checking those solutions, the only one that does work is 7. The rectangle has a width of 7 inches. Okay, 2 more examples for this section. The top of a local cable television tower has several small triangular reflectors. The area of each triangle is 49 square centimeters. The altitude, which is the height of each triangle, is 7 centimeters longer than the base. Find the altitude and the base of one of the triangles. So I remember back to 7th grade or even 6th grade, our area formula is 1/2 base times height. Remember, height is our altitude. So we can let B plus 7 equal the length of the altitude, because it's 7 centimeters longer than the base. So we'd be adding 7. And then we can replace that into our formula here. So A times B, or base times height, right, divided by 2 equals 49. Remember, 49 was our area here, square centimeters. So we said base times height, but our height is B plus 7 times B. Well, we can distribute that out and get B squared plus 7B over 2 equals 49. And then we can multiply both sides by 2 to get rid of this fraction. That gives us 98. And then we can rewrite this in the quadratic form. Factor out b minus 7, b plus 14. So how did we get those factors? Well, we know it's 1b, so we'd have to have b and b. It's b times b is b squared. And 7 times 14 is 98. One of them has to be negative to equal a negative 98. But one of them has to be positive, so that when we add them together it equals 17. And we can get that by checking our outside, 14b, and our inside, negative 7b, and 14 minus 7 does equal 7. So we can solve for b, set these both equal to 0, b equals 7, b equals negative 14. Plug this back in to check your work. It cannot equal 14 with the checking. 7 is the only one that works because 7 plus 7 equals 14 centimeters.